Okay. Assalamu alaikum, guys, and good evening. Actually, today we have people here. Where were you guys earlier? कल बहुत सारे लोग नहीं थे. Siddika, you also like left in between the class. What happened yesterday, Siddika?
Sir, my Wi-Fi disconnected yesterday.
उसको connect कर लेते फिर.
No, sir, it was the.
अच्छा, ऊपर से खराब मतलब ऊपर से.
Yes, sir. Yes,
आगे से
it
प्रॉब्लम.
जी.
प्रॉब्लम. Okay, so yesterday I gave you some homework. Mariam and Sarah, who both were present, gave you some homework, right? Class में जो आपको मिला था, Learnivio से जो आता है message बोनी, you did the first one. That means you did the smaller one, right? जो हल्का था काफी, right? That was molecular orbital theory of lithium. So send me the photo. Okay, send me the photo.
1 minute.
Okay. So O2 हो चुका है अब, and you have also done O2
Sir,
positive.
should I send two?
हाँ, Mariam, you also please send. You have done both of them, Mariam?
Yes, yes.
I
don't know if it is correct, but I tried.
No problem. Yeah, fine, no problem. I will let you. And see, guys, those who missed last class was very important. Okay, so complete molecular orbital theory of all the diatomics are done from hydrogen till oxygen, O2. Now we have just one thing left, and all the basis, everything that I taught yesterday will be used today for this case, and after that I will be talking about the weak forces, especially I have hydrogen bonding that is present. The hydrogen bonding is there in your syllabus in NCERT for chemical bonding, but there are a few more weak forces. For example, dipole, dipole, dipole induced dipole, and then you have London dispersion forces, van der Waals forces. These are also weak forces that you must have idea about how they act and how they influence different properties in a substance. So actually, let us start with after O2 we will just have what? After O2 we are going to have oxygen, and after oxygen what is the atom after oxygen, guys? What is the atom after oxygen? Anji. What comes after oxygen? Fluorine. Okay, so we are going to do fluor. बाकी लोग अभी सिर्फ कहानी सुने है ना. Try to understand a bit. Otherwise, so 6th and then 7th is our fluorine F2 molecule. Mariam and Sarah, help me here. Siddiqa also. Total number of electrons?
18.
18. 18. Yeah, my bad. 18. Correct. So case 1 or case 2?
Case 2.
Case
1. Case
1. So case 1, that means it will be 1, 2, 1. 1, 2, 2, 1. So let us start with molecular orbital electronic configuration. चलिए सारा अभी बोलिए कुछ तो. चलिए. We'll start from sigma.
Sigma 1s2.
Sigma 1s2.
Sigma star 1s2.
Sigma star 1s2.
Sigma 2s2.
Sigma 2s2.
Sigma star 2s2.
Sigma star 2s2. And now comes the issue. अब बताएं क्या है?
Sigma 2pz.
After that?
Pi 2px is equal to pi 2py.
Equal to pi 2py है ना. बाकी लोगों को तो लग रहा है क्या चल रहा है सर, कहाँ आ गए हम लोग. 11th की क्लास है ना, और कीजिए आप. एक क्लास बच्चे मिस करते हैं सोच के क्या ही हो जाएगा क्लास में. दुनिया ऐसी बदलती है. So we have how many electrons? 18. So we have done 6 14. And 4. 14 are done. अभी तो 10 हुआ
No,
है ना?
wait.
11, 12, 13, 14. After that?
Sigma star 2p. No.
Sigma star.
Pi
Pi2p.
Pi star 2px equal to
2px. Pi
pi star
2pi.
2py. Now here how many?
4.
Here also 4.
Yeah, 1, 2.
गलती हो रही है क्या? के बाद तो खत्म हो जाएगा फिर इसमें। अच्छा नहीं बॉन्ड बन जाएगा, ठीक है, 1 2 3 4, ठीक है। चलिए बॉन्डिंग एंड एंटी बॉन्डिंग स्टार्ट करते हैं। So this will be bonding molecular orbital. This is ABMO. This is
BMO,
BMO,
ABMO,
ABMO,
BMO,
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 BMO ना, BMO,
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 and ABMO.
ABMO and ABMO. Just give me a second. Select the product. Okay, see here guys. So 2ps and 2p5. Fine. Now let's start with number of bonding. Number of bonding, it is equal to how much? 2.
10.
10. Number of anti-bonding?
8.
8. Bond order?
1.
ठीक है, चलिए अब आ जाते हैं, एग्जिस्ट करेगा नहीं करेगा? एग्जिस्ट,
Yes.
राइट?
Exists.
पैरा और डाया?
Para.
पैरा कहाँ है? अनपेड इलेक्ट्रॉन?
Oh, dia.
डाया मैग्नेटिक ना, has no unpaired electrons. चलिए, any problem till here? हाँ जी, any problem?
No, sir.
नहीं ना, किसी को दिक्कत तो नहीं? Write this down. Let us move on to the next one. Last खत्म कर देते हैं फिर Ne2 करके, ठीक है ना? Ne2 and don't write anything else ना, bond order हो गया, exist diamagnetic, right? Nothing else to write here. Write the 8th one. Ne2 molecule. So total number of electrons?
20.
20. Just a second. Total number of electrons is equal to 20. So case 1 or case 2? Case
1.
Case 1. 1, 2, 2, 1. ठीक है? So molecular orbital electronic configuration. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. अब इसके बाद क्या आएगा? Sigma 2pz. 2 can have pi 2px equal to pi 2py. Now pi 2px and pi 2py में 1 electron, 2 electron, 3 electron, 4 electron. Then we will have pi star 2px equal to pi star 2py. 1 electron, 2 electron, 3 electron, 4 electron. Then you will have sigma 2pz, sigma star 2pz rather, and you will require 2 electrons to complete the 10, to complete the 20, right? सही है, no problem ना?
Yes, sir.
देख लीजिए एक बार. We count the bonding, anti-bonding. This is bonding, anti-bonding, bonding, anti-bonding, bonding, 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 anti-bonding, anti-bonding, anti-bonding. Number of bonding, it is equal to 10. Number of anti-bonding, it is equal also to 10. Bond order is equal to 0. Therefore, any two does not exist. And जब एग्जिस्ट ही नहीं करेगा तो डायमैग्नेटिक पैरामैग्नेटिक करके क्या करेगा, है ना? सही है.
Yes, sir.
Write it down. Everyone done? Listen to Sunny.
Yes, sir.
So we have discussed everything regarding the molecular orbital theory. Okay. Yeah, everything is done. There is just one thing that I want to tell you guys. Okay. So in general, for example, let me take the example of this fluorine F2 molecule. Okay. Now, if you look at the F2 molecule here, copy this, hold on. I hope you must be wondering that, sir, how do we write the molecular orbital configuration if we have large atoms? You know, for example, fluorine is only what? Fluorine is only having 9 electrons, right? So in these cases, what generally we do is we just write the valence shell. So rather than starting from the sigma 1s, we generally start with the valence shell. That what is the valence shell here? The valence shell is going to be starting from 2s. So I will start from sigma 2s. Okay. To talk everything about the molecular orbital configuration, and we write this as kk. We write this as kk. कुछ आप बताइए, what is kk? के बताइए, व्हाट इज के पता चल रहा नहीं पता चल रहा? के नहीं पता चल रहा है? अरे वन फर्स्ट शेल को क्या बोलते हैं? व्हाट इज फर्स्ट शेल नोन एज? के ना?
K sir.
क्या? हाँ, तो so these are the molecular orbital made by the first shell orbitals, है ना? This one s is also in K. This one is also in K, right? So that is why I write KK instead of this sigma 1s and sigma 1. Sure? And then rest of them is written as it is. Okay, so you can also write it as. Then again start with the whole thing, this part here. Achha, also one more thing. I hope I have told you guys that whatever boxes we are making for the orbitals, those are not actually required, but we write it just for our cleanliness and not to make mistakes. Right? Yes or no? Because it is very easy. As you can see in sigma 2px, 5 2px, we can sometimes, if we have only 2 electrons left, then rather than writing 1 1 like this, we can easily do something like this, right? This can be a very easy mistake. Right? So in order to avoid this, what do? We write like this and then put the electrons. And after putting the electrons, we write, okay, when you have 2 electrons here, you have 2 electrons here. You have 2 electrons here, we have 2 electrons here. Okay.
Yes sir.
Right. So this is everything regarding the what I would say, the molecular orbital theory. Yeah? Now you have to write the topic that is important topic. It is not really related to chemical bonding. You will not be asked any questions in the chemical bonding. One topic that you will ask is hydrogen bonding. Otherwise, you will not be asked about anything else. Whatever weak forces, you know, the topic that we are going to learn right now, it is weak forces. So please write. Weak forces. Okay. Now in weak forces, we are going to learn about a few terms. Okay, we are going to learn about a few terms. And what are weak forces actually? Weak forces are types of, they are not complete chemical bond. So the chemical bond that we have generally, those are what? Those are ionic bond, covalent, and coordinate. But apart from these attractions, ionic bond is also what? Attraction between two atoms. Covalent is also similar thing. Coordinate is also similar thing. But if we have attraction that does not reach to the level of these chemical bonds, we call them weak forces. We call them weak forces. Okay. So we are going to learn about a few weak forces. Write the number 1. Although, by the way, all the weak forces, they will arise because of polarity. They will arise because of polarity. That's one point. It should be very clear. All weak forces arise due to polarity. All weak forces arise due to polarity. That means if you have A, B, right, and there is some A is a bit more electronegative, so it will get delta negative because it is pulling electrons from B, and B will get delta positive. Now, similarly, if you have another molecule of A and B, Now here also A will have delta negative and B will get delta positive. Now, as you can see, this B is having delta positive charge, this A is having delta negative charge, and this both of these plus and minus can interact with each other. They can have some kind of attraction. And this type of forces are generally known as weak forces. Huh? Now, it would depend on the level of delta positive and delta negative that we have. If A is very electronegative, so it will be very highly delta positive. It will be highly delta negative. It will be having a high negative, partial negative charge, even though it is going to be partial, but it will be high. So if we have very high charge, partial charges also, they are not pure charges as in the case of cation and anion. They're not pure cation and anion, but they have partial charges which are very high. And because of them, there is some attraction between two different molecules or two atoms of different molecules, two atoms which are not bonded together, right? So in those cases, we say that there are weak forces. We say that these are the weak forces. And all the weak forces, they will arise only because of this kind of polarity. They will arise in this case, in the case of polarity. Okay. Now, write number 1. Write the number 1. Van der Waals forces. Van der Waals forces. Now, what are Van der Waals forces, please? Let us suppose we have some we have some molecule like this. And this molecule on its own, it does not have any delta positive or delta negative charges. It does not have any delta positive or delta negative charges. But as you know, in the molecule, it will be made up of atoms, and outside atoms, we have electrons, right? So definitely, if the molecule is made up of atoms and outside atoms, we have electrons. So outside molecules also, we will be having electron cloud. Yes or no, please tell me. Correct?
Yes, sir.
Okay. Now, and electrons, they act as a wave. They act as a wave. They are electron cloud. There are probability densities of different types of different electrons. Now, let us just imagine for a moment, momentarily speaking, for a moment, what happened? For a moment, all the electrons, for a moment, 1 second, not 1 second, 1 nanosecond also, all the electrons are by chance situated here. And most of the electrons, they are revolving. Obviously, electrons will be revolving because they are wave in nature. And so what happens for 1 instant, all of these negative charges will be at one side for a moment. Now, definitely for a moment, because of the absence of electron, this will be getting positive charge, even though it will not be pure positive. But if you have a sea of electron, and in the sea of electron, there is a hole, for example, जैसे मान लीजिए ना, you have एक आदमी के पास है 10,000 रुपए, 10,000 छोड़िए, 10 लाख रुपए, 1 2 3 4 5. Okay, they have 10 lakh rupees. He's not poor, right? Yes or no? Tell me, guys. If he's having 10 lakh real, 10 lakh real, he's not poor, right? Is he poor?
Yes, no.
Mariam? No, obviously not. But what if he stands around let us suppose the Saudi royal family? Will he feel poor? If he stands, he will not feel poor. If he stands with MBS and King Salman and King Mohammed bin Salman, like the royal family, then obviously he's surrounded by cars which are gold. They're not actually car, but they are like ornaments. Obviously, if he's having this much money, Abdullah Farhazi is saying, yeah, definitely he will, right? He will be feeling poor. No? If he's surrounded by everyone, like Ambani, Adani, if he comes to India, then he will be feeling poor, right? So in this case, what happens if we have a site? Mariam, convinced? Nahi convinced? हम तो poor नहीं feel करेंगे. I am rich in my mind. ठीक है? ऐसा है क्या मरियम?
नहीं.
नहीं ना? ठीक. He will feel poor, right? I hope you understand.
Yes.
Similarly, yes. Here, when you have negative charges at one side, and here you don't have any electrons, and earlier it used to be some electrons here, right? There used to be some electron, but there are no electrons here, so it will be what? Positive, positive, positive. Now listen very carefully. This is the case. As soon as there will be positive charges here, these positive charges will attract the electrons of the another molecule adjacent to it. And this will also become what? Delta positive, sorry, positive, negative, positive. Can you see this happening? Yes or no? Please tell me. These positive charges, what did they do? They attracted all the electrons in this side. So positive, idhar aa jao, idhar aa jao. Got it, guys? Yes or no? Please tell me. Now you can perfectly see if I have A here and I have B here. If I have A here and I have B here, then A is getting delta negative for a moment. B is getting delta positive for a moment. This A here will also get delta negative and this will get delta positive for a moment. All of you got this, guys? Yes or no? Please tell me.
Yes, sir.
So momentarily speaking, we have a dipole. So this type of dipole is known as instantaneous dipole. Got this? Yes or no? Please tell me. This type of dipole is known as what? It is known as instantaneous. That means it is for an instant. It's happening because of an instant. Okay. So here we have instantaneous. Obviously, it will be very weak force. It is the weakest force that you can have. It is the weakest force that you can have. Please write. Caused by instantaneous dipole. Caused by instantaneous dipole. Now, अब देखिए, चलिए थोड़ी सी हम लोग बात करते हैं कि the factors which affect the van der Waals force of attraction. Factors which affect the van der Waals force of attraction. This is very important. Okay, ध्यान सुनिएगा. This is going to be used in your 12th standard also. If you don't, अभी हम पढ़ाते हैं आपको, उसके बाद हम एक डाउट दिखाएंगे आपको. That was asked by a 12th standard student, है ना? So he joined Learnivio in 12th standard only, and he asked me a doubt. ठीक है, तो हम आपको दिखाएंगे इसके बाद. चलिए देखिएगा. When we talk about van der Waals forces, then what is happening? There is distortion of electron, right? Electron का एक तरफ हो जाए. If electron can get distorted easily, we will have more van der Waals forces. Yes or no, guys? Please tell me. Correct है? बात समझ में आ रही है ना?
Yes, sir.
अब ये बात बताइए. एक बात बताइए आप इस तरह से कि इलेक्ट्रॉन्स आर वेव है ना, तो इसको डिस्टॉर्ट नहीं करो, खुद से हो रहा है. They are getting distorted on their own. Please tell me, what is the probability? Where is the probability higher? Where is the probability higher? If you have large number of electrons, then obviously the probability of distortion will be higher, right? Because what is getting distorted? Electrons. If you have more electrons, the probability of getting distorted will be higher. Yes,
sir.
So we can say one thing. That van der Waals forces force is directly proportional to ease of distortion in electron cloud. Now, this is directly proportional. Okay, this is proportionality sign. Alpha nahi hai. Directly proportional. Now that means it will be directly proportional to the atomic number, or I could say atomic mass. Atomic number or atomic mass. Why? If we have a high, see, generally textbook and everyone else, they will say you atomic mass, because van der Waals, when he was there, atomic number was not a prevalent factor. Okay, the atomic number was not a prevalent factor, and we did not talk about the atomic number at that time. We usually talk in terms of atomic masses. That is why it has been written as atomic mass. So if we have larger atomic mass, so obviously there will be larger number of electrons. And when there is larger number of electrons, the ease of distortion increases. And if the ease of distortion increases, van der Waals force of attraction also will increase.
Yes, sir.
Okay. Next is, please see. Next. Let us suppose I have a small molecule like this, and I have large molecule like this. Now, if there is some distortion, what distortion can happen here? Can any distortion happen here? And if that distortion will be there, it will be like negligent distortion. अब यहाँ पे अगर हो जाए मान लीजिए negative negative, तो बताइए आप कितने दूर हो गए negative और positive, right? This is high level of distortion, right? Yes or no? Please tell me. बात समझ में आ रही है?
Yes, sir.
Yes, sir.
That means it is also directly proportional to the size of atom. My bad, size of molecule. Okay, size of molecule. Is this clear? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
No. Another thing that we can say here is, please see. I'm going to make some molecules here. Okay, I hope you can understand a few. नहीं समझेंगे तभी कोई दिक्कत नहीं, हम समझा देंगे आप लोगों को, ठीक है? When I talk about size of molecule, उसमें आप समझिएगा जरा. Let us suppose I have 5 carbon atoms like this. This is 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. You must have seen this type of carbon atom जब आप लोग 10th class में soap पढ़ रहे हैं, right guys? Long chain, and then we have COO, negative, Na positive. कुछ याद आया? नहीं याद आया किसी को? Hydrophobic, hydrophilic.
Yes, sir.
Hydrophobic part कुछ याद आया किसी को? हाँ मरियम, नहीं याद आया?
Yes, I remember.
Yes, Mariam?
I remember.
You remember. What about others? Sara, Siddiqa, bond line structure of carbon atoms. If you have CH3, CH2, CH2,
Yes, sir.
CH2 and CH3, it can be written as like this. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. These are carbon atoms. You guys remember now?
Yes.
Okay. What about others? Sara, Siddiqa, Martin, Yasir?
Yes, sir. Kind of.
Kind of. No, fine. That's it. Now, see, here we have 5 carbon atoms. Okay. And here also we have 5 carbon atoms. 4 and then 1 branched. Fine. Then if you look properly, here also we are having 5 carbon atoms. 1, 2, 3, 4. And then another CH3 is here. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. Okay, so all of these are having 5 carbon atoms. But can you see a significant decrease in the size of molecule? Yes or no? This is having large size followed by this and then followed by this, right? This is having, see how large it is. And this is quite small. If you see, we have, because like this. And if you come to this, it is almost like a sphere. Now, what is happening here? We are having 5 carbon atoms, but what is happening here? The branching is increasing. The branching is increasing. And if the branching increases, the size of molecule decreases. The size of molecule decreases. Please, you will write. This is very important. As branching increases, size of molecule decreases. Therefore, van der Waal force of attraction, van der Waal forces decreases. That's it. Now, सबको है ना?
Yes, sir.
जी बताएं. If there is any doubt, please let me know.
Done, sir.
Done. See here. Atomic mass, and van der Waal forces, right? All of these things. Now, the student asked something, but he did not write it very properly. This was this. Assalamu alaikum, sir. This is recently only. That is why I remember. He should have asked in a other way around, sir. How does molar mass depend on van der Waal forces? That's not right. Rather, it should be how is van der Waal depending on molar mass? Okay, so he is having this doubt from 11th standard. Can I tell you the reason? The reason is states of matter is removed from your syllabus. States of matter, right? If you have the textbook, you just read the first page of states of matter. It deals with all of these different forces of attraction. Now, van der Waals forces, we have different categories of van der Waals forces. Okay, we'll talk about that also. So he's having this doubt. Why? Because its application is there in 11th standard in the if we are going to talk about the melting point and boiling point of different organic molecules, then it is applied in the hydrocarbons chapter, but it has not been taught in the states of matter. So hydrocarbon में जब जाइएगा, I will directly be writing. अगर आपको विश्वास नहीं हो ना, ये देखिए, as branching increases. Now please tell me if we have high force of attraction. If we have AB molecule, है ना, one molecule AB, another molecule AB, another molecule AB. Okay, if these are attracted they have strong forces of attraction. If they are having strong forces of attraction, then breaking them apart will be difficult. Correct, guys? Yes or no?
Yes, sir.
That means if they are, let us suppose in liquid state, if they are in liquid state, then to convert them to gases, it will be difficult to convert them to gases. That means if they are having high force of attraction, if force of attraction is higher, then what is going to happen? The boiling point will also be higher. Correct, guys? Yes or no?
Yes, sir.
So van der Waals forces is what it is. As branching increases, size of molecule decreases, van der Waals forces decreases. Van der Waals forces decreases, right? So please see, I can write now boiling point is inversely proportional to branching. Branching increases, van der Waals forces decreases. Van der Waals forces decreases, boiling point decreases. समझ में आ रही है?
Yes, sir.
आप देखेंगे एक चीज, ट्वेल्थ क्लास, ठीक है, हैलो एल्केन हैलोरीन इस चैप्टर. Can you see this? Tell me. Boiling point inversely proportional to branch. है ना? ये देखिए बहुत इंपॉर्टेंट है. Boiling point inversely proportional to branching. ठीक है? So it is going to be very important. अब ये देखिए हमने कुछ explain नहीं किया यहाँ पे. You have directly written ना. Otherwise, if you see here when I am teaching you guys, then C2 में आ गया, C1 में है ना. ठीक. So see, we have to discuss a lot of things here, right? But this is the conclusion. And we are going to directly use the conclusion in the 12th standard. Also in the 11th standard, by the way. Hydrocarbons जब आप पढ़ेंगे. ठीक है? Moving on, please see. We have discussed this van der Waals forces. ये application वगैरह हम लोग देख लेंगे. Application इनका क्या है? Melting point and boiling point की जब हम बात करेंगे, then what is going to happen? The melting point and boiling point, it is going to depend directly on the van der Waals forces of attraction. चलिए. We can write therefore melting point and boiling point of noble gases increases down the group. Why? Because if you look at the noble gases, then the atomic mass will increase and the size will also increase as we go down. Molar mass is also increasing, the size is also increasing. So van der Waals force of attraction will also increase, and van der Waals force of attraction is directly proportional to the boiling point. And boiling point directly depends on the van der Waals forces. Got this? Yes or no? Please tell me.
So can you repeat?
Once more. See, boiling point.
No, but he just said.
Is directly proportional to van der Waals forces of attraction. If you have high van der Waals forces, they will be attracted together, and that is why the boiling point and melting point also I should write will be directly proportional, right? And as you know, if I go down the group, then what happened? Size also increases and molar mass increases. Okay.
Yes, sir.
Done everyone? Yes, no, please tell me.
Yes, sir.
ठीक है. अब वैंडरवाल फोर्सेस जो है ना वो 3 टाइप के होते हैं. एक तो ये इंस्टेंटेनियस वाला आपको समझा दी, बाकी 3 में भी सिमिलर चीजें हैं. प्लीज सी. पहले को बोलते हैं डाइपोल डाइपोल फोर्स. Other one is known as dipole induced dipole. And the other one is known as forces or instantaneous dipole, जो हम लोगों ने exactly पढ़ा. Okay, London. Dispersion forces. Okay, dipole dipole में, for example, if you have HCl and another HCl, so chlorine is more electronegative, it will have delta negative, this will have delta negative, hydrogen will have delta positive, this hydrogen will have delta positive. So obviously, both of these are going to attract each other. Both of these are going to attract each other, right? And when both of these are going to attract each other, then I mean there is no instantaneous part here, right? It is already always present. So it is not a temporary. It is what we can say that it is a permanent dipole. All of this, all of you understood this? Yes or no? Please tell me.
Yes,
So what
sir.
will happen?
Yes,
This will be
sir.
always present. Now, dipole induced dipole, it is also temporary. Why? Because, for example, I have something like this, CH3 and CH3. Now, CH3, there will not be any dipole moment here. There will not be any dipole that is delta positive, delta negative, because both the carbon atoms, they are same thing, right? तो अच्छा कार्बन हटा दीजिए, आपको ज्यादा हो जाएगा. आप बहुत सस्ता एग्जांपल ले लीजिए H2 का, हाइड्रोजन एंड हाइड्रोजन. So both the hydrogen, they have same electronegativity. So that is why there will be no delta positive, no delta negative. But let us suppose there is NH3 here. Due to NH3 here, this nitrogen will get what? Delta negative, and the hydrogen will be having delta positive, and delta positive. And let us suppose we have one hydrogen here, H2 molecule. So when you have one H2 molecule here, this delta positive will be attracting the electrons from hydrogen and making this delta. They will be attracting electron, right? So this will be delta negative. Or ये क्या हो जाएगा? Delta positive. Similarly, this nitrogen's delta negative, and also there is a lone pair. This lone pair and this hydrogen, on this hydrogen atom, it will be pushing the electrons away. So this will become delta positive and this will become delta negative. And then they can have interaction. This positive and negative can have interaction. These positive and negatives can have interaction. All of you got this? Yes or no? Please tell me. So इसको बोलते हैं induced dipole. देखिए, hydrogen did not have dipole until and unless NH3 is present. है ना? Got this, guys? Yes or no? Please tell me.
Yes, sir.
Yes or no? So this.
Yes, sir.
So what is happening? There is a dipole which is induced by another dipole. ठीक है? So hydrogen कुछ नहीं, आराम से. But hydrogen got a dipole because of NH3. So dipole induced dipole. Then we have last, that is the London dispersion forces that we talked, which is most difficult to understand, है ना? Instantaneous वाला. वो हम लोगों ने अभी भली अच्छे से समझ ही लिया है, ठीक है ना? This is the instantaneous example. So I start with the instantaneous and then I move away and tell you that, okay, fine, there are types and this is the toughest one to understand. But now you know, all of these are what different types of van der Waals forces, and all of them, they depend on these things only: ease of distortion of electron cloud, atomic mass, and size of molecule. Now, moving here, London dispersion forces, I will say this is instantaneous. and temporary. Also, it is the weakest. Got this, yes or no, please?
Yes.
Yes, sir.
All of you wrote this down also?
Yeah.
Okay. Now moving on, that is the next one. The second weak force that we have to understand is the hydrogen bond. Hydrogen bonding. Okay. What is hydrogen bonding? Please write. Please write the definition of hydrogen bonding. It is an electrostatic force of attraction. It is an electrostatic force of attraction. It is an electrostatic force of attraction between covalently bonded hydrogen atom, covalently bonded hydrogen atom of one molecule and an electronegative atom and an electronegative atom. And this electronegative atom is either fluorine, oxygen, or nitrogen. Okay. मतलब समझिए जरा. For example, please see. For example, if I have HF, okay, HF, you have another HF, you have another HF. Now, what is happening here? See, delta positive, delta negative, delta positive, delta negative, delta positive, delta negative, right? Now, because fluorine is the most electronegative element in the periodic table, the partial positive and the partial negative charge on hydrogen and fluorine respectively will be very high. And it is higher than all of these different dipoles. है ना? यहाँ पे भी HCl पे dipole है, pure dipole. Similar dipole is present in HF, but because of its very high polarity, we have given it a different name. And this polarity is so high that means it is like, you can say that it is 10 times, 20 times more than what the previous van der Waals forces. So see here, this red line, it is the hydrogen bond. Okay, this red hydrogen of one atom, electronegative element of another atom. This is hydrogen bond. This is hydrogen bond. This one is not hydrogen bond. This is covalent bond. This is covalent bond. Okay, this is covalent bond. All of you got this? No. उसी तरह से देखिए. For example, if you have, let us suppose, what do you have? You have ketone. If you remember this, CH3 carbon with a double bond oxygen and CH3. So this oxygen, it has lone pair electrons, right? And then you have water. So water has a formula that is hydrogen bonded to oxygen, then hydrogen. So this hydrogen will be having delta positive. This will be having delta negative. Now this oxygen atom, because it is having lone pair electrons, right? It is having two lone pair electrons. So obviously it is going to have delta negative charge. It is because it is bonded with carbon atom. Now both of these can also interact. And they can form hydrogen bond. Okay. So when you have hydrogen attached to, what you have to see? Hydrogen covalently bonded to hydrogen covalently bonded, and fluorine, oxygen, and nitrogen. Wait a second. Covalently bonded to electronegative element. And F or O or N is nearby. Nearby matlab is in another molecule. Okay. Now there are two types of hydrogen bond. Is right. Okay. Types of hydrogen bond. One is intermolecular hydrogen bond. And the other one is intramolecular hydrogen. Okay. Let us see both of them. So intermolecular between two molecules. Okay, so the hydrogen bond is involving two molecules. Intra means in one molecule. So between two molecules, we have seen the example of hydrogen bonding. For example, you have HF, right? So HF. Okay, so this is intermolecular. So you have one molecule and then the other molecule, and both of these are bonded with hydrogen bond. Similarly, for water, you can write H, OH. Then again, you will have oxygen here. Let us suppose oxygen here. Then you have hydrogen here. You'll have hydrogen here. So this. So these are what intermolecular hydrogen bond. So we have involvement of at least two molecules, and hydrogen bond is between two molecules. In intramolecular hydrogen bond, what we will have in intramolecular hydrogen bond, for example, we have a very good example that is also being used later on, that is O-nitrophenol. अब आप लोग को O नाइट्रोफिनॉल थोड़ा दिक्कत होगा, but don't worry, ऐसे आपके एग्जाम में अभी नहीं आएगा, बाद में हम लोग पढ़ेंगे इसके बारे में. Okay, we have benzene ring, and then we have OH, that means phenol. OH. Then you have nitrogen like this. Okay, nitrogen, it has a double bond, and then it has oxygen like this. Now this oxygen and hydrogen, they will be having, this is what, this is intermolecular hydrogen bond. Can you see the difference here? Yes or no? Please tell me. In both of these.
Yes,
ठीक है, अब ध्यान सुनिए ना. See, बहुत ध्यान सुनिए, ठीक है ना. When you have intermolecular hydrogen bonding, the bonding is between two different molecules. So different molecules are attracted towards each other. Different molecules are attracted towards each other. And when different molecules are attracted towards each other, boiling them and melting them becomes difficult, because we have attraction between the molecules, between the particles, between the constituent particles, right? So what will happen? Boiling them, that means converting them to from liquid to vapor will be difficult. Converting them from solid to liquid will also be difficult. But when you have intramolecular hydrogen bond, one atom is having hydrogen apne aap mein, he is not even caring about the other molecules, right? If you have solid, liquid, or gas, if you have solid or liquid, let's leave gas. If you have solid and liquids, the solid is not made by one atom, one molecule. until and unless you have billions of molecules around you, it is not a solid. Until unless you have billions of molecules around you, it will not be liquid. Because solid, liquid, and gases, these are defined only on the basis of what? When the atoms are closer together, atoms, not atom, atoms are closer together, they are solid. When they are a bit far apart, liquid. They are too far apart, gases. So obviously you need to have atoms. And when there is attraction between atoms, then what is going to happen? Then boiling them or melting them will be difficult. But in the interim, in one molecular having hydrogen bond, what is kya hone wala usse? There's nothing going to happen with the molecules, the atoms or the molecules that we are going to have, right? So the adjacent molecule of this O nitrophenol, this is known as O nitrophenol. This is known as O nitrophenol. O nitrophenol. मतलब ओ इसका ऐसा पुकार नहीं रहे हैं कि आपको आ जाओ इधर, ऐसे नहीं बोल रहे, नाम ही है ओ नाइट्रोफेनॉल. ओके, so in this O nitrophenol, it is having hydrogen bond in on itself. It is not attracting other molecule. Then the other molecule will also not attract other molecule. So there is no attraction when you have intramolecular force of attraction. There is no intermolecular force of attraction when you have intramolecular hydrogen bond. Okay, so एक दूसरे के molecules में you are not going to have any force of attraction. That is why boiling them will be easy. Okay? So here, please see another point which is very important. Melting point and boiling point. It is directly proportional to intermolecular hydrogen bond. अब अगर आपको कभी कंफ्यूजन हो जाए कि इंटरमॉलिक्यूलर में दो मॉलिक्यूल आएंगे या इंट्रा में दो मॉलिक्यूल आएंगे, तो आप ये याद रखिएगा, इंटर स्कूल कॉम्पिटिशन. डू यू गाइस हैव इंटर स्कूल कॉम्पिटिशन? हाँ जी.
Yes, sir.
So who participates? Only one school or different school in the area?
Different schools.
So different, two more than ना, एक से ज्यादा. Between two different molecules. Competition होगा तो अलग अलग school. Bonding होगी तो अलग अलग molecule. When you have intra school, inside one school. Inside one school only. Intra means एक ही अंदर. है ना? So when you have, I don't know what groups you have in your school, but generally there are houses, right? There are generally houses in the school. So when the competition is inside the school between houses, it is inter-house or you can say intra-school. In the school itself, there is some competition. Okay. So, but ये आप inter याद कर लीजिए, आपको intra याद रह ही जाएगा. There are only two types of hydrogen bond. And now with this topic, chemical bonding is complete. Okay, the end हो चुका है chemical bonding. Now there is one. I have on 26 ना, हाँ ठीक है. Next week I will be taking classes. Next week में I will be not taking class on Saturday. वो हम आपको अगले हफ्ते बता देंगे. Next week तो हम सारी classes ले रहे हैं, सारी classes. Okay, I will be absent for a few days. I have to go to Mumbai to bring my degree. मेरे बैच में सारे बच्चों ने डिग्री ले ली, हमने अभी तक डिग्री नहीं है ना, because I mean I was not asked about my degree anywhere, but बच्चे बोल रहे हैं कि ले लो जाके, वरना बाद में लाइक माय क्लासमेट्स आ गई खो वो जाएगा कहीं पे, वो लोग भुला देंगे, फिर बाद में तुमको बहुत ज्यादा परेशानी होगी. I mean I did not have my 10th certificate. I had my 10th certificate only after completing masters. I mean, I did not need it anywhere. I don't know why, but after completing my masters, I then went to Jamia Millia Islamic. I mean, I have done my 10th and 12th